going to be learning lesson 2.2, dividing whole numbers by fractions. Okay, so our learning target for today is I can divide whole numbers by fractions. And we're going to start off with a word problem to kind of wrap our mind around what this means. Okay, so here we have a piece of wood is 3 feet long. We want to know how many 3/4 foot pieces can you cut from the piece of wood, from that 3 foot long piece of wood. Okay, so the expression that we are solving is going to be 3 divided by 3/4. Okay, we want to see how many 3/4 foot pieces fit into a 3 foot long board. All right, we're going to start by using a model. Okay. All right, so what we're going to do is we're going to start out by drawing the 3 foot long board, and I'm going to separate it up into like 1 foot sections just so that we can see each 1 foot section. Okay, but the real board obviously is not split up like that. All right, and I want to know how many 3/4 pieces can fit into those 3. So my first thing I'm going to have to do is divide it into divide it into fourths. So I'm going to divide each board into fourths. Notice how there's 1, 2, 3, 4 pieces of each foot. Okay. Now if I want to see how many 3/4 fit in there, I'm then going to be circling groups of 3. Okay, so I'm going to circle groups of 3/4, which if it's already cut into 3/4, I'm just going to be circling 3 pieces to make 1 group. Okay, so it's going to look like this. 1, 2, 3. That's 1 group of 3/4. 1, 2, 3. That's our second group of 3/4. All right, 1, 2, 3. That's our third group of 3/4. And 1, 2, 3. That's our fourth group of 3/4. Okay, so this tells us that we can cut 4 pieces that are 3/4 foot lengths from this 3 foot long board. All right, now if that model didn't really make sense to you, that's okay. I'm going to show you another type of model that we can use. Okay, this is called a number line model. We are practically going to be doing the same thing. Okay, I'm going to start off with a number line. So if here's my line, I'm going to put 0 at the beginning, and I'm going to put 3 at the end because it's a 3 foot long board. Then I'm going to make a 1 and a 2. It doesn't have to be perfect, but it's got to be close. Okay. Again, if I want 3/4 foot pieces, I'm going to have to divide this number line into fourths. Okay, so I'm going to use a different color to do that, just to make it easier for you to see. All right, we're always going to start with where we, like the length of our board. Okay, so if the length of our board is 3, we're going to start here in 3. And we are going to count groups of 3/4 again. Okay, because we want to know how many 3/4 fit into this 3 foot long board. So here's 1/4, 2/4, 3/4. Here's 1 group of 3/4. Here's 1/4, 2/4, 3/4. Here's our second group of 3/4. Here's 1/4 and 2/4 and 3/4. Here's our third group of 3/4. And then we have 1/4, 2/4, 3/4. Here's our fourth group of 3/4. So again, we will determine that you can cut 4 pieces of 3/4 foot long boards from that 3 foot board. Right. Now our 6th grade standard is that we do need to know how to model these. So you do need to know how to do one of these models. You don't have to know how to do both, but you do have to pick one that you like more, and then that's the one you're going to want to practice. Okay, because 6th grade says that you need to know how to do this. However, 6th grade also says you need to know how to do it using the algorithm. Okay, which means that we're just going to be dividing without doing a model as well, but you do need to know how to do both. Okay. To divide fractions, you multiply by the reciprocal. And you're probably like, Miss Lakin, what in the world is a reciprocal? Okay, so two numbers whose products are 1 are called reciprocals. Okay, to write the reciprocal of a number, you write the number as a fraction. So let's start with 1/2. Okay, to write the reciprocal of 1/2, we invert the fraction. That word invert is explained down here in the picture. Okay, when you invert a glass of water, you turn it over. Okay, so when we invert these fractions, we're turning it over, or we're flipping it. Okay, so the reciprocal of 1/2, if we flip it, is 2/1. Okay, now it says that reciprocals products are 1. Product is multiplication. So if I multiply 2 times 1, I get 2, and 2 times 1, I get 2. 2 divided by 2 is 1. Okay, so if you ever want to check to make sure you wrote the right reciprocal, you can multiply them together, and you should always get the same number over the same number, which gets you to 1. Okay. To remember how to divide fractions, we use a phrase. Okay, a phrase that's catchy, just kind of reminds you of the steps. So to remember the phrase, we use keep, change, flip. Okay, what this means, we are going to keep the first number. I'm just going to use a pound sign, a number sign, a hashtag as a number. Okay, if you don't know this hashtag is representing a number, don't write it. Write out the word number. Okay, so we keep the first number, keep that first fraction. Then we change division to multiplication. Okay, sorry, to multiplication. And then we flip the second fraction to its reciprocal. All right, let's go through some examples. We have 3 being divided by 3/4. Now, just like when we multiplied fractions, our very first step is to make that whole number a fraction. And to make the whole number a fraction, you divide it by 1 or put it over 1. Okay, so when we rewrite this as a multiplication problem, to divide this fraction, we keep, we change, we flip. Okay, so we keep the first number. We keep 3/1. We write it exactly the same as it was. Okay, we change the division to multiplication. And then last but not least, we flip 3/4 to its reciprocal, which if we flipped or turned it over, we'd have 4/3. Okay, at this point, you can do 3 times 4 is 12. 1 times 3 is 3. And then just reduce, how many times can 3 go into 12? Or you can think about it as 12 divided by 3. That's going to give us 4. Notice this is our same problem as above, so we knew that we should already get 4 because of our 2 models. Okay. One thing with this problem is we can also cross simplify. So you could have chosen to do it that way, or when you have 3/1 times 4/3, you could notice that our cross products, 3 and 3, can be both divided by 3 to make it 1 and 1. So you could also do 4 times 1/1, which would also give you 4. Okay. Again, you don't have to use cross simplifying, but it is a nice tool if you can master it. Example number 4. What I want you to do with this example, since it's very similar to the last one, is I want you to pause the video. I want you to try it out on your own, and then resume the video so that you can check your answer. Okay, so pause that video now and try to solve it on your own, and then resume. Okay, our first step is going to make that 5 into a fraction by putting 5/1. Then we are going to rewrite it. We're going to keep, change, flip. Okay, we are multiplying by the reciprocal. So we have 5/1, keeping the first fraction, changing the division to multiplication. You can use a dot, you can use a star, you could use parentheses, and then we're going to flip that second fraction to its reciprocal. We're going to flip it over. So we have 9/7. At that point, we just multiply across. There's no cross simplifying that we can do here. So we have 5 times 9, which is 45, and 7 times 1, which is 7. Okay. At this point, we are going to determine our mixed number because we have to simplify this improper fraction. Okay, if you can do it mentally, that's great. If not, make that long division problem. 45 goes inside, 7 goes outside. 7 goes into 4 0 times, but 7 can go into 45 6 times because 6 times 7 is 42. Last but not least, we subtract to see what's left over. We have 5 minus 2, which is 3. 4 minus 4 is 0. We ran out of numbers, so we now have those 3 important numbers for our answer. Okay. When we write this, our answer is up at the top. So we have a 6 as our whole number. The remainder is always the numerator of our fraction. It's our top of our fraction. And then our divisor is our denominator, that bottom of the fraction. So we get 6 and 3/7. Okay, you could have also done that mentally, but if not, use that long division method. It gives you those 3 important numbers you need. All right, we have one more word problem and then we are done with this lesson. A serving of tortilla soup is 1 2/3 cups. A restaurant cook makes 50 cups of soup. They want to know, is there enough to serve 35 people? Okay, so the expression that we are dealing with, we have 50 cups of soup and we want to see how many times 1 2/3 fits in to 50. Okay, so we're dividing those 50 cups of soup into 1 2/3 cups for those servings. Okay, so we are dividing. That's an ugly division symbol, sorry. Okay. Now here we don't have to do a model. You could choose to do a model, but 50 is going to be a crazy model to be doing. So this is when that algorithm comes in handy. Okay, so first step is going to be putting 50 over 1. And then I'm just going to copy everything else down. That's our first step. Second step is going to be changing this mixed number into an improper fraction, just like when we had multiplying fractions, we have to make them improper when we divide. Okay, so we're going to keep that first one, 50 over 1, because it's already an improper. And now we're going to be dividing by 1 2/3 improper. So we take our 1, which we do our mad, multiply 1 times 3. Then we do the a, which is add that 2. So we have 3 plus 2, which is 5. That's our new numerator. Denominator stays the same, 5/3. Third step. We keep 50 over 1. We change division to multiplication, and we flip 5/3 to its reciprocal, 3/5. Fourth step, we just multiply across. We have 50 times 3 over 1 times 5. All right, 50 times 3 is 150. 1 times 5 is 5. Now we are going to make that into a mixed number. So we put 150 inside, 5 on the outside. 5 can't go into 1. 5 can go into 15 3 times. 5 times 3 is 15, so we subtract to get 0 left over. We have that 0 left, so we just bring it up. And here we have 30, because we have no remainder, 30 cups of soup. Okay. The question asks, is there enough to serve 35 people? Well, if this only makes 30 servings, our answer would be no. 50 cups. We always want to use answers or numbers when we are explaining our math answers. 50 cups would not. I'm going to skip down to the next line because of this little logo. 50 cups, sorry, would only serve 30 people. I'm using a number again, not 35. Okay, so we want to include our answer when we're explaining a math solution, and then compare that to what they wanted us to compare it to, which is 35. So no, 50 cups would not work. It only would serve 30 people, not 35. Right. If you have any questions, you can rewind and rewatch any of the video or write it on your Cornell notes and then ask in class.